In this lesson, we are going to talk about the rules of significant figures. Significant figures are important because they tell us something about the precision of the answer, and our answers to calculations cannot be more precise than the numbers that went into those calculations initially. First, we'll go through the rules for determining significant figures, and then we'll look at some examples. The first rule is that any digit that is not 0 is significant. This is the easiest rule. When we get into looking at zeros, things get a little bit more complicated. So if it's not a 0, it's significant no matter where it is in that numerical value. When we look at the number 1.234, we have 4 non-zero digits, so all of those values would be significant. Next, we'll look at zeros that are between non-zero digits, and they are always significant. So in 606, the two sixes are significant because they're not zeros, and the zero in between is significant because it's between two significant figures. Placeholder zeros, which happen in a value that is less than 1, are not significant. They're simply making sure the 8 is in the right decimal place, but those numbers themselves are not significant. Now we need to look at zeros that fall at the end of a number, and this is where things get a little bit more complicated. Let's look at the first example here. For numbers greater than 1, all zeros to the right of the decimal point are significant. So we have 2.0, and in this case that 0 is significant because the number is greater than 1 and the 0 is to the right of the decimal point. And this tells us that we know that answer precisely at 2.0. Saying we know the value to 2 milligrams is not as precise as saying we know 2.0. So when we look at 2.0, we see that it has two significant figures. For numbers less than 1, only the zeros that are at the end and in the middle of the number are significant. So when we look at the value here, 0.00420, we see that those first three zeros are not significant. Those are simply placeholder zeros. They're making sure that the 4 and the 2 are in the right decimal place. When we look at the 0 at the end, it is significant because it is a 0 at the end of the value after the decimal point. And that tells us we know that answer to that level of precision. And this value, therefore, has three significant figures: the 4, the 2, and the 0 at the end. There are some numbers that we don't look at when we're determining significant figures, and these are known as exact numbers. These are obtained by counting, such as having 8 people or 6 eggs. We can't have 6½ eggs or 6 2/3 of an egg. We have either 6 eggs or 5 eggs or 7 eggs, but we have a whole number, so that is an exact number. When we look at 2 units in the same measuring system, so 1 quart is defined as 4 cups. That is a definition, that is an exact number, and so it will not affect our significant figures when we use that in a calculation. The same is true for anything in the metric system, so all of our relationships from the metric system are also considered exact numbers. One exception is when we're dealing with inches and centimeters. So this is between the metric system and the English system. And notice that most of our exact numbers actually end up being whole numbers. That doesn't mean that all whole numbers are exact numbers, but many of our exact numbers are whole numbers. One exception here is 1 inch equals 2.54 centimeters. This is actually a definition, and this is considered an exact number. So this is one of the few places where we see a number that's not a whole number that is still considered exact. Exact numbers are always excluded when counting significant figures.